Okay, so you upload a video to some site, you hit that button, and now you are just sitting there, staring at a spinner, 20 seconds, 40 seconds, a minute. And behind the scenes, what is happening is real heavy work. The server has to encode the video, compress it, make all the different quality versions, and that genuinely takes, let's say, a solid 20 seconds. But the user does not know any of that. All they see is a spinner that will not stop. So they refresh, which sometimes fires the whole thing off again, and honestly, a lot of them just give up and leave. And it is worse than just one annoyed user as well. Remember from the latency video, while that one person waits, a whole connection on your server is stuck open, doing nothing but babysitting that one slow job. Now, picture 1,000 people uploading at once. You only have so many connections, and every single one is now stuck, holding a slow upload button. So, new users show up, and there is no free connection to even serve them. The whole thing jams up. Everything just waiting on everything else. So here is the question that fixes all of it, and it is almost embarrassingly simple. Why are we making the user wait at all? Like, does the user actually need to sit there and watch their video encode? No, they just need to know we got it and that we will handle it. So what if we could just say got it instantly and do the slow work afterwards, after they have already moved on with their day? So at high level, up to now, this whole series has kept one shape. A request comes in, the server does the work, and an answer goes straight back. Every single video, that same shape. And this is the very first time we hit a case where the shape itself is the problem. So here is the shift. And honestly, this is the heart of the whole video. You take that one request and you split it into two separate things. One, the part the user needs right now. Yep, got your video, we are processing it. And two, the part just needs to eventually happen. The actual 20-second encode. And the move is you answer the first one instantly and you go and do the second one later, quietly in the background, after the user has already gone. Now, I have to be really clear about one thing because it is the number one thing people get wrong about this. This does not make the work faster. The video still takes 20 seconds to encode. We did not speed anything up and we did not make the work disappear. All we changed is that the user does not have to watch it happen anymore. And that is the one line worth saying out loud. A queue does not make work disappear, it just lets the user stop waiting. And one more thing to plant right now, because it is what people get most wrong about this. It is not about machines or adding more servers. It is about time. Pulling the slow work out of the moment the user is sitting there waiting. A queue is about time. And notice this quietly changes what your response even means, right? Before, when your server said success, it meant done. Here is your finished thing. Now, success means something a bit different. It means accepted. I have got it. I will do it. And HTTP actually has a code for exactly this. You saw status codes in the HTTP video. It is a 202, which literally means accepted, but not finished yet. But that hands you a small new job. Since you are not giving back the finished thing anymore, you now owe the user a way to find out when it is actually done, a little status they can check, or a notification, an email once it is ready. One quick catch, this only works for a certain kind of work. Things the user do not need to sit and wait for. A video encode, an email, a report. It does not work when they need the answer right now to carry on. A search result or is this username taken? Because then a queue just starts a pointless wait. So the litmus is simple, right? Does the user actually need to wait for this result? No. Send it to the background. Yes, keep it live. Okay, so how do we actually do this? Handle it later thing. This is where the queue finally shows up. So, the app that took the upload does not do the 20 seconds of work itself. Instead, it just writes a tiny little note, a job, that says encode video 42, and it drops that note onto a queue, which is just a line, a to do list of pending jobs waiting to be picked up. And then, off to the side, a separate little program pulls those jobs off the line one at a time and actually does them. And those two parts have names, right? The front tab, the one that takes the request and hands off the job. We call that the producer. And the thing pulling jobs off and doing the actual work is the worker, sometimes called the consumer. So, producer drops the job off, worker picks it up. That is the whole machine. And there is one rule here that really matters. Get it wrong and you will lose people's work. You had to get the order right. The producer has to put the job safely onto the queue first and then tell the user accepted. Never the other way around. Because if you say you have got it and then try to save the job and your server hicks up in the split second you are in between, that job is just gone. You promised the user something you never actually wrote down. So save it first, confirm second. It is the same idea from the retries video, right? Do the durable thing first. And here is the part that actually matters. The slow work is now on its own, separate thing, sitting behind the queue. So, what happens if the jobs pile up faster than one worker can get through them? You just add more workers, two of them, five, 10, all putting up from that same one queue, all chewing through the jobs at the same time. And notice what that gives you. You can scale the slow part, the encoders, completely on its own without touching the fast part that talks to the users. The thing that was jamming everyone is now the one thing you can grow by itself. And there is a second, completely different thing the queue does for you. And this one is not about adding workers at all. Think about a sudden spike. Let's say your site goes viral and 10,000 people upload in the same minute. Without a queue, all 10,000 of those encodes slam into your servers at the same instant and melt them. But the queue absorbs that. The flood just piles into the line, and your workers keep pulling from it at their own steady pace, whatever the pace happens to be. So the burst out front becomes a calm, steady stream at the back. The queue is the shock absorber. It decouples how fast work arrives from how fast you can actually do it. But, and this is the honest catch, and it sets up the next video. A queue buys you time, not capacity. It is a shock absorber, not a bottomless bucket. Because if that flood does not stop, your work just keeps arriving faster than your workers can finish it. Then the line does not magically shrink, it just gets longer and longer. Job starts waiting minutes, then hours. You have not solved the overload, you have just delayed it. And at that point, your only real options are add way more workers or at some point actually start refusing work. And knowing when to say no, I am full, that is a whole story of its own for the next time. Okay, before we wrap, two honest catches you have to know because do it later is not entirely free. The first is simple. It is now eventually done, not immediately done. That confirmation email lands 2 seconds later instead of instantly. Usually totally fine, but it means you have to actually design for that little gap. No more assuming the work is finished the moment you reply. The second catch is sneakier and it ties right back to the retrace video. So, a worker grabs a job, gets halfway through it, and then crashes. So, the queue is sitting there, never hearing done. So, it very reasonably hands the same job to another worker to try again, which means a job can run more than once. This is called at least once delivery. And it is just how a lot of real queues work. If the job was charge the card or send the email, you could charge them twice or send them the same email twice. And the fix is exactly the one from the retrace video. You make the worker idempotent, which just means doing the job a second time does nothing extra. The worker checks, wait, did I already do job 42? And if so, it just stops. So honestly, a queue is precisely where that idempotency idea ends its keep. And one last little piece. What about a job that is just plain broken, that fails every single time you try it? You do not want it retrying forever, and you really do not want it clogging the line for all the healthy jobs waiting behind it. So, after a few failed tries, you just pull it out and drop it in a separate pile. It has a great name, a dead letter queue. Basically, these ones failed. A human should come and look. So, one poison job cannot jam everything else. So let's tie it all together. The whole thing in one sentence. A queue does not make work disappear. It just lets the user stop waiting. You accept the job fast. You drop it onto a queue. And a worker finishes it later. Accept queue work. And once you see that shape, you start noticing it everywhere. Sending emails, encoding videos, generating reports, running a big AI job over a batch of files, firing off notifications. Anything slow that the user does not need to sit and watch quietly slides off the live path and onto a queue. And yes, the tools that do this have names like Kafka or RabbitMQ or SQS, but they are all just doing this one simple thing. And remember, right at the start, I said this was the first time in the series one shape breaks. Well, that's it. The answer comes back first, and the real work happens after. But we left one big thread hanging, right? What happens when that queue just keeps growing and your workers can never catch up? At some point, the honest move is to stop accepting the work at all before the whole thing tips over. And that how a system protects itself by saying no is exactly where we go next. But for today, don't make the user wait. Accept it now, do the work later. See you in the next one.